Hi, and welcome to this recast for Unity 3D. This is to recap what we have seen in class so far, and to give more of an overview of the Unity 3D interface. As you can see, I'm starting off with the default layout. You just select it there. I have my hierarchy on my left, where it's supposed to be, and I have my project on the bottom, well, I guess it's bottom 3/4. Console is with it, and I don't have the one column layout. If you don't know what that is, if you select one column here, it will change the look to make it look like this. Some people prefer that. I actually do prefer it, but for simplicity's sake, I'm just going to leave it with the default. Inside of my hierarchy, I have one camera and nothing else, and I have no assets imported, just like we did in class. Alright, so to do a quick overview of this, which we haven't really done in class, I'm using the Mac version. This is Mac version 4.6. You can get Unity 5 for free. You can get Unity 4.6 for free. Some of the differences are many for the 4.x versions. The version 5 has some things that you can't really do, but not as many as the 4.x versions. We go to the file menu, we can do a new scene or open a scene. We can save the scene. Now remember that the scene is part of the project. If you want to think of scenes, they're levels. If you're making a game, you load different scenes for different levels. You have a new project, open project, save project. I'll just go ahead and make a new project right now, and I'll save this as teaching. Doesn't matter. I'm not going to import any packages. Remember that when you're doing this in class, you want to actually save it on your desktop or in your documents folder. I'll set up my defaults this time for 2D, just for a change of pace, and click Create a Project. It's asking me if I want the new version. I do not. And I'll switch my layout to default. Now, as you can see, the scene view looks different because it's in 2D mode, and you might want to go ahead and start setting it to 2D mode, because that's what we're going to work with. We're not going to do any kind of 3D stuff. Just keep it simple with 2D, although some people would argue that 3D is actually easier, but we're not talking to those people, so we don't have to worry about what they have to say. Looking at our tabs here, we have the game view. Now, whenever you're actually in the game view, you're seeing things as if you have finished programming your application and you build it and you actually want to publish it. This is what you would actually be seeing. Okay? And that's why, to give any input into your application, whenever you actually get it running, you have to have the game window in focus, which means you have to have it selected. Okay, if you click over here and you're messing around in your hierarchy and you start clicking some buttons on your keyboard or on your joypad or joystick or controller or whatever you want to call it, and nothing's happening, well, that's why, because you don't have the game view in focus. Project view is where we actually bring in all of our assets to use, or where we create assets. Assets, again, could be defined as anything that we plan on using inside of the game that is of code or media content. So any images that you want to use, any sounds, any videos, although videos are not really recommended at this point. Although you could. If you want to make some kind of media player or something for your project, then of course you want to have some kind of videos for testing, if nothing else. The console window is where we we'll see any error messages or really anything that Unity has to tell us as far as problems or inconsistencies with code, etc., etc. This is also where we actually, whenever we use the debug class and call the log method, whenever we're testing or whenever we're learning these different functions and how to use them, you'll actually see whatever you use in your debug log output here to the console. The inspector shows you all of the information available with the current game object you have selected. If I select this main camera game object, you'll see that it has a transform component, a camera component, a GUI layer, flare layer, and audio listener components. Now, the way things work inside of Unity, everything is on a game object. And now, that's not always true. There are things called scriptable objects, but that's far beyond the scope of this beginner's class or beginner's course. So the idea is that you go to game object, you create an empty game object, and you name it whatever you want to name it. Say I'll name this one, I'll just call it test game object. And all game objects come standard with a transform component. Now, what these things in the inspector are, these things that have the drop down, these are all components. And you can say, you can select here add component, and there are a lot of different things that you can add. You can add an animation to this, you can add a skybox, a lot of different things that you can add. You can add a UI element, which we'll get to that soon. Or you can add a script that you create yourself, which is what we've done in class so far. Everything over here, all of these components are all different classes, and they are actually instantiated just for the simple fact that you have them attached to a game object. Now, there are other ways to instantiate objects, but those are more like dynamic instantiations. These are like static instantiations. No matter what we do, this will actually be inside of this program. Okay, what we're going to do here, and I'm going to just do exactly what we did in class. Now, there's two ways we can do this. I can go create the C# script like we did in class, or since I want the script to actually be attached to this game object, I can just go to add component, new script, my language is C#, and I'll call this hello world. Click create and add, and it adds it automatically. So if you did it the other way, like we did in class, to actually get this class, any of the code to actually run inside of your application, you have to instantiate it. You have to make it exist inside of the scene. So to do this, you can make a blank game object like this one and drag it over. Excuse me. Or you can use an existing game object too, if we're just doing testing purposes. You don't have to use an empty game object if you don't want to. It just depends. Whatever object that you attach this code to, you have the ability to change anything else about that object very easily. Okay, if we wanted to make changes with the camera, not the best way, but the easiest way to do that would be to make a script that actually, maybe we want the camera to pan across the screen at a certain angle, or to look at a certain object at all times. For beginning programming, the easiest way to do that would be to make a script that would control all of that behavior and then attach it to that camera. So all of the code that would control the camera would be on the camera. Now, that's not a prerequisite. You can have other objects or code that actually control objects that it's not attached to. So you don't have to do it that way. But just as an example, okay? So I have mine attached to this have my hello world script attached to my empty game object. It's not entirely empty. It does have a transform component. So we'll just double click this and open it in Monodevelop. Should look exactly the same as we used in class. We have a start function or method, and we have a void function or method. Up here we have which collections we're importing. This is not important for right now. Here we see we are inheriting from the MonoBehavior class. That is not important at this time either. We'll get into that later. If we don't get into that, well, we'll just see how it works out. Remember that the start method runs once whenever the scene is actually started. There are other functions that are included in Unity. The reason that these two are included by default are they're the most common ones people use, especially for people just learning how to code. We will look at some other ones later. The awake function, the fixed update function. We'll look at those later. But for right now, these are the two we're going to work with. The start, again, it runs one time whenever the scene starts. The update function runs once per frame. So it can be thought of as constantly. And that's not necessarily true if you're going by the exact definition of the word constantly. But for the purposes of this beginner's class, you can think of it that way, that this is something that runs all the time. So what we did in class is we just did which is customary whenever we start a new programming language or a new programming interface, we use the convention of the Hello World program. We use a debug. We inherit, or not inherit. We're going to call a function on this debug class, which is included inside of Unity. We haven't looked at this yet, but I will go ahead and show you where we actually get all this stuff. Okay, inside of the namespace Unity engine, which we're inheriting from the Unity, we're actually including the Unity engine assembly. We can look through here and find all the different classes that are actually defined inside of this. Okay, if you want to see all of the classes that you can actually take advantage of, we can go and open a browser window. Hopefully my internet's not being extremely crappy like it usually is. But you can go to this website, docs.unity3d.com, which we will be looking at this in class, and I'll go back to Unity while this is taking forever to load. I'm actually currently downloading the 10.10.5 updates for Yosemite, so that's why it's going to be taking a while. But what this is a scripting reference. You can go here and look up any class to find out more information about it, or if you're trying to find how to do things, this is a great place to go. Alright, so here at the documentation, you can go up here and click the scripting API. And this is called the scripting reference. Now, what you can do, well, first of all, you have your scripting language over here, whether you want JavaScript or C#. We'll be using C#. And we have all of the built-in classes that come with the Unity engine assembly. Look at all these classes. We have animation, we have the debug class. So we click on the debug class. This is a class containing methods to ease debugging while developing a game. And we have log. Logs messages to the Unity console. So if we click here, we can see the exact specifications of it. We have two different overrides. We have, which that doesn't mean anything right now, maybe it will later. We have two versions we can use. Okay. We have the message, which is a string or object to be converted to a string representation for display. So what we're trying to say, and it has to be in a string format or an object format. So for most purposes, it's going to be a string. Okay, you can see here that it's actually expecting an object. It's going to be called a message inside of this. You don't actually have to worry about that. The only thing you have to worry about is actually giving it a string whenever you call it. And just like we did in class, this is how we do it. We say debug log hello. Okay, and this selection I have is optional. You don't actually have to have it. You can just say debug log hello, debug dot log, I should say. Remember that whenever you're doing these class calls, that capitalization does count. You have to have a capital D, you have to have a capital L. The rest of them have to be lowercase. But anyway, we'll look at this documentation later. But whenever you're actually building your application, you'll be using this a lot. Okay? So back to Unity. Actually, back to Monodevelop. Alright, so if I say debug log, and again, this is called making a code skeleton. I'm not actually just going to go like this, where I make a parenthesis and then I start typing right away. No. The best way to do it is to make a skeleton. Type in the class you're using, type in the function name, and put in all of your syntax right away. Then you can go back and fill in the pertinent information. So, hello world. Save. And we go back to Unity. Press play. And we see that nothing happens. And why is that? That's why, because I haven't instantiated this class inside of the program. Now, I did it before, but I didn't actually save, and I had a computer crash. I had to pick up where I left off. So I'll just do it again. Create an empty game object. Drag the hello world script over. Play. And you'll see here at the bottom it shows me the most recent console logging. Alright, the most common way to actually look at the console, though, is to actually go to the console, and you can see I have one message, I have no warnings, and I have no failures, more or less is what this one is. Okay, these are going to show up as red, these will show up as yellow, and these will show up as white, just like you see here. So it only shows up one time because I have it inside of my start function. If I move this section of code to my update function, that means that this will show up once per frame, and you can see the number rising and rising and rising. Okay. Inside of class, we created our own function, and you can see right here exactly how it's done. You start out with your return type, which we'll get to later. For right now, just use void. The name of the function you're going to create. Parentheses here indicate any kind of parameters that you're going to set up for your function. It's optional. You don't actually have to use it. So we say I'm going to make a function and call my function. Actually, let's not do that. Let's call it say hello. And again, you'll see that I make a skeleton of my code, or of my function. I don't type it in as I go. I type it in once, then space it out. Okay? The say hello function, the only thing it's going to do is debug log the hello world thing again, and I'll just call this through function. Okay, and again, this string is not important, it's just important that it is a string. This is just what I want the console to say. It's to let me know that this function is actually working correctly. Alright, so instead of doing the debug log instead of the start, I can just say hello. Alright, go back to Unity, clear my console. Hello world through function. Okay. Now it's important to remember something else. The play settings. The way Unity works is that if you make any changes to your program while it's playing, whenever you stop, the savings or the settings that you change or anything that you change won't be saved. So I could have this saved and say I want to actually delete this game object, and that's all well and good, but whenever I stop the program, the changes that I made while it was in play mode don't exist anymore. So that's important to remember. Something else is you can't save a scene while it's in play mode. Okay? Alright, so let's take a look at another of Unity's built-in classes. Let's see. The input class. This is the interface to the input system. We use this class to read the axes that are set up in the input manager and to access multi-touch or accelerometer data on mobile devices. Alright, so let's look at the kind of functions that we have. We have these variables, and we also have some static functions. The one that we used in class was the getAxis function. Returns the value of the virtual axis identified by axis name. So let's go take a look. There are no overrides for this. It's just inside of the getAxis we provide the string that we're trying to find, or that we're trying to get. Okay. So down here we can see that inside of update you can make a float called translation. It's equal to input.getAxis vertical multiplied by speed, and speed is set up here, which we haven't gotten to this part yet, but we did get to this. Okay, we looked for input.getAxis vertical. Okay, well, where is this defined? What does this mean? Well, let me show you. Inside of Unity, if you go to your edit, I think it's edit, yes, edit, and you go to project settings, here are a lot of things that you can actually change about your project as far as well, settings, more or less. That's why it's called project settings, I guess. So if we go to the input settings, and you'll see it show up over here in the inspector, and you have this drop down called axes. If we click here, we see all of the axes that have been defined and what they are. We see that the horizontal axis is the left and right keys. Here's another horizontal axis. This is set by the actual joysticks. Okay, joystick axis. This is a key or a mouse button. Okay. We also have alternative buttons for each of these. We have an alternative negative button, which means -1. So the float that will be returned from input.getAxis will be -1. That will be the A key. If you want it to be +1, it will be the D key or the right key. So this is actually where you would set this up. Now you could come in here and let's say I want to change the name of the vertical, and I want to change it to vert. Okay. So let's go into Monodevelop, and I say, for example, I want to check and see if anyone is actually pressing the left or right keys. If I get axis horizontal, I can say debug log horizontal is being pressed. Okay, save that. And if I go back to Unity and press, oh, I have a problem. Oh, that's right. Sorry. And remember, we saw this in class too, is input.getAxis horizontal returns a float value. And a conditional statement, like this if statement, can only check booleans. It can only see if something is true or false. And, you know, if 1 or if 0 doesn't make any sense. So the logic here is if input.getAxis is 0, that means that no one's pressing left or right. If input.getAxis is not 0, that means that someone is pressing left or right. So what we want to do is do a check and say, well, if getAxis is not equal to 0, then that means someone is actually pressing a button. Okay? So now we can save this. Should go away. Now we press play. And if I have the game screen highlighted and press left or right, we can see that the console is updating with horizontal messages. Okay, so what if we want to go and check the vertical as well, like we did in class? If I check vertical, alright, so can I do this? Yes, I can. And you're going to say, well, wait, you changed it. You changed the name, which I did. I changed it to vert. But there's still a vertical axis that exists down here. Okay, so that's why it's not actually giving me an error. Normally, if you try to check any kind of axis that doesn't exist, and I'll show you, I can just change this to vertical 2. And then I try to hit play, it's going to throw me an error every update. Input axis vertical 2 is not set up. What it's saying is that I haven't defined it in the input under axes. Okay, so, and if I just leave it at vertical, it's never going to actually find anything. It's never going to actually trigger because I have changed that name. So horizontal works, but vertical, it does not. The vertical axis that still exists is checking for something on a controller. Alright, so if I go back and I change this to what I renamed it, now when I press horizontal, horizontal works. When I press vertical, vertical works. Okay? So, this is how we actually will get input from the user as far as directional keys or whatever. And we can take this information and actually send it to a game object or whatever. We can do something with this data to see how we actually can really quickly grab this data. We can use concatenation and say, I want to actually output whatever input get axis horizontal, and I'll say, and its value is, and it's going to grab this value and output that. So it's either going to be 1 or -1. Okay, so we can save this and take a look at how that works. So now if I press horizontal to the right, it's 1 or almost 1, as you saw at the beginning. whenever I let off, it actually gradually goes back down to 0. And whenever I press it, it gradually goes up to 1. If I press the left key, or the A key, you'll see it gradually goes down to -1. And whenever I let off, it gradually goes back to 0, and then stops the output. So you could take that value of -1 or 1 and do something with it, like tell a game object to move. A game object that has a character mesh attached to it, so it looks like a character. So that's how you actually move the character. You actually get the input and then forward that information to the object to actually make it move. And we'll see how to do that in class, and we'll see how to do that in my next reclass video. Alright, so hope this helps with any doubts that you had as far as using the Unity interface. All of these other things, the game objects, components, we'll review these, or we'll look at these as we go. Some of these we may not even get to. Maybe the navigation, the navmesh agent, and the offmesh links, we'll probably won't even get to that stuff. Probably. Alright, so again, see you in class, and we'll pick up where we left off next time. Thank you, and have a good night.